I just thought I would go over some of the naming which we were learning about yesterday and applying, or well, today if you're listening to me. Again, I thought I'd just run over just so you have like a little bit of a video to watch about how to do it. So again, we went through some pretty basic rules when it came to naming stuff. So you need to first figure out if it's ionic or covalent. That should be relatively easy to do when you're looking at ionic substances. They're between a metal and a non-metal, so you should be pretty good at that by now. And binary covalent. Covalent just means it's between non-metals. And sorry, my stomach just gurgled there, so you may have heard that. But anyway, we'll move on. So I thought I would just kind of run through a bit of a demo with you just in case like it's not making sense in your head. So I'm going to give two examples now. So the first step is we should be able to go from a formula to a name, and it's actually really quite easy. Okay, so what we need to do is we need to look at our element and figure out first if it's ionic or covalent. And for me, I've split these, but that's an extra step you'll have to do. And in the worksheet, I'll kind of tell you that example. So in particular here, I have got an element, and I know that I've got a compound actually. And I know that I have an element, and it's potassium and iodine. I know that those are the two elements, and potassium is a metal, iodine's a non-metal. So I already know it's an ionic formula, okay, which means it's going to have a fixed amount. You can only have potassium iodide in this ratio here. All right. So what I need to do is to convert that to the name. I just need to write the name of the metal. So in this case here, it is potassium. Now, since it's the first one, we don't change its name. So what I meant to say to you is the name doesn't change. Now, it is a metal ion, and ions respond charged, but all we're doing is writing the name here. So I've got potassium, awesome. And I then need to write the name of the metal ion, but I need to change its suffix. So I need to change that last bit. So potassium, I know it's going to be iodine, so iodine. But what I do is rather than make it INE, all right, so backwards. So this is technically what I've written. So I've written the name, but what I need to do is I need to create an INE and make it IDE. So this is technically called potassium iodide. All right, so this is potassium iodide. So that's what we got there. And again, works out. I think we've done pretty well there. Second one, I'm going to do it as well. This is also an ionic substance. So this is ionic. This one is also ionic. So what I need to do is I need to write down the name of the first metal following the rules. So this is magnesium. All right. And the second one is fluorine. All right. Whoop. I always get this wrong. I always write it so. Fluorine. Let me just double check that. Yep, it's O. It's U before O. I always get this. So I always say like fluorine for some reason. But anyway, so this is fluorine. But again, it's the second of the two. So it's the second one. So we need to make it IDE. But the cool thing about ionic substances is it doesn't matter about this too. We don't put a prefix in front of this one because magnesium fluoride can only be in this way because remember, magnesium will technically have a 2+ charge and fluorine will have a 1- charge, which actually means you need 2 fluorines for every 1 magnesium, and it's always going to be the case. It's not a covalent compound. So you'll only ever find magnesium fluoride in this way, so hence why we can just call it that. It's a bit of a shortcut. Now the next one, the reason why we call these binary covalent is it's just 2 elements because covalent compounds can get really, really large. If you think about things like carbohydrates, you know, glucose is one, it's C6H12O6. That's going to make naming a bit tricky, but we're just going to learn about them in terms of pairs. So this one's here pretty easy. What you need to do is you need to write down the name of the first element, and you don't change its name. So generally, it's always going to be the first one here. There's a few reasons why the first one is there, but you'll learn that a bit more next year in first year chem, if you do year 11 chemistry. But what we need to do is we need to write down the name of the first element, write down the name of the second element, we change it to IDE, and again, we always need to focus on our prefixes here because our covalent compounds can form in many different ways. If I tell you nitrogen oxide, that could be dinitrogen oxide, that could be nitrogen dioxide, that could be dinitrogen monoxide, that could be, who knows? It's almost, it could be in any sort of form, all right? So that's why we need to put those dis and tris in. So this example here, I think we already know. We're going to write the first name down, and this is carbon. But in this case here, carbon has only got one of it, so I'm not going to put mono because we don't put mono at the front of the first name, and that's because it's assumed otherwise. But the second one I'm going to write down, so this one's going to be oxygen, but oxygen has a bit of a weird one where we write oxide, so it's always going to be oxide, okay? But if we remember, how many oxygens are there? There are 2. So we always need to put a suffix on the second one, no matter what. Even if it's 1, we still put it there. And what we do is we go to our table to figure out what we put on the front. Now, carbon here has got 1, so it's got 2, sorry. And we go over here and we can see that we're meant to put di as the prefix. All right. So in this case here, this is going to be carbon dioxide, hence why we call it carbon dioxide. Now, what we do is we do the same thing for the next chemical. So again, I can already see that, and I'm going to write nitrogen. Let's do that a little bit better. I'm just rushing myself for some reason. So I'm going to write nitrogen. All right. And I need to have a look first. So I need to write down if it's greater than 1. If there's greater than 1 atom in that molecule, I need to change it. So in this case here, I already know there's 2, and our 2 prefix is di. So I need to write dinitrogen. All right. And I need to look at the second elements. So again, I can see that there's only 1 oxygen, but because it's the second one, we always need a prefix. This is going to be monoxide. All right. Now remember, technically, if you were to write this properly, see how it has mono? You would actually write mono. Or when I say correct, what I mean is you would probably write it like this, but that doesn't make a whole lot of sense, right? So what we do is we knock off the O from the front. It's not monoxide, it's just monoxide. Comes with the tongue a little bit better, and is a little bit better as well. So hopefully that makes sense there. So carbon dioxide, dinitrogen, monoxide. So we always name this, and it tells us the numbers, which actually makes writing its chemical formula super easy. All right. Oh, why did I get rid of that? So hopefully that makes sense. That was just going from formula to name. So remember, you need to go, I know that this is covalent, or I know this is ionic, and then you need to then do the structure to get that way. Okay? So you can follow those steps that are there. Now, writing names to formula is actually really easy, but it's a little bit trickier for ionic compounds rather than covalent compounds, just due to the fact that ionic compounds don't have those prefixes. So therefore, we actually need to do something called the crossing over method, which I showed you. So what I need to do is, I need to first, when it's an ionic substance, now this is metal, non-metal, metal, non-metal, hint, hint, you should always check first what you've actually got, whether it's ionic or covalent. But in this case here, I already know what's going on. So what I'm going to do is I'm going to write down the symbol of the metal. So in this case, it's beryllium. So I'm just going to do that to the right-hand side. Come on. So I'm going to do Be. And when I go to my annotated periodic table, I find out here that actually beryllium has a charge of 2+. So when it undergoes and becomes a compound, it releases 2 electrons, hence why it's positively charged. So I'm going to write above it. You can either write +2 or 2+. It really doesn't matter. So I'm going to do 2+ there. And then what I'm going to do is I'm going to write down the symbol of the metal. That's not meant to be the metal. That's meant to be the non-metal. So in this case here, because it's ionic, we know that's the case. So in this case, I'm going to put chlorine. So I go back to my periodic table, and chlorine is in that 7th group. So it's actually got a -1 charge. So in this case here, I'm going to put Cl, -1. Now, what we do is to make things easier, we actually do something called a crossing over method. So what I'm actually going to do is I'm going to rub out their charges, because their charges don't matter in this case. All right, and I'm going to do something where we cross over and swap the partners. All right, so when I go to completely write this, I will have Be1Cl2. Now, we don't write this 1. Okay, whenever we see this 1 here, we're actually always assuming it's there. I mean, technically you could write it, but most people, convention doesn't say that we do. So what we do is when we are fully writing this molecule, all right, everything just kind of went crazy there for a minute on my screen. All right, so now we go to beryllium chloride, and that is now the fixed chemical formula of beryllium chloride, and it can't be anything else but that. That's why ionic substances are so easy to name, is because you can do that method. All right, now, if we have a look, that's relatively easy, okay? Beryllium, chlorine, beryllium chloride, we've got a fixed ratio. Same one as well, we'll do that for sodium. We're going to write down sodium, which is Na. All right, we're going to write down fluorine, which is F, and we're going to write down its charges, but I'm going to do this time is not write down that the positives and negatives, because it really doesn't matter. But it's good to know that you know that the metal is always going to be positive, non-metal is going to be negative. If I do that crossing over, I get Na. And again, I'm just going to assume that these are 1s, and I've got sodium fluoride. All right, pretty much as easy as that. Okay, there are some ones which become a little bit tricky, and probably, I'm trying to think if there's one of the cases. Oh, I might pause this and re-upload it maybe. There are some where it can, oh, actually, no, I don't think there's any cases where it can be really tricky, to be fair. Pretty much, if you always swap them over, you always get the right one. I'm trying to think of a case where that wouldn't exactly work. The only thing would be sometimes if you did this method with like carbon dioxide, it wouldn't work because of the numbers. But yeah, really, I think that should work for every single case. Let me know if it isn't, and I'll have a go. But that's naming ionic substances. Super easy. It takes a little more thought than covalent, but it still works. So what I do is I'm going to show you this one. So covalent, when it's a simple binary pair, you've got to write down the name of the element symbol first. So for that one, look at the prefix. And if there's no prefix, you're just going to assume that it's 1. So it's actually really easy. These names give you the numbers of atoms to write. It literally tells you. It's actually so much easier. So carbon monoxide, carbon, there's no prefix in front of it, so it's just going to be a 1. Okay, there's only going to be one of them. And monoxide just means one oxide. So when I write it, carbon monoxide. Easy as that. All right, now this one is when we need to look at these dis and tris. So this is where when we're looking at covalent naming, it becomes a little bit more trickier. But this is where you need to use your table at the moment to have a look. And what I can see here is I've got a chemical called disulfur pentafluoride. So di meaning 2, penta actually means 5. So when I go to my table, di, penta. So what I need to do is write down the elements first. So what I'm going to do is I'm going to write down sulfur, which is S, and fluorine, which is F. All right. But I have only written one of each. So I actually need to tell you, and you need to tell me how many of each symbol there are. So in this case here, it's going to be disulfur, which means I need to put a little 2. And penta means 5. So to write that, it's going to be disulfur pentafluoride. Hopefully that makes sense. But definitely this crossing over method works really well. There are a couple of tricky ones, particularly when it comes to things like aluminium, because it kind of can get a bit tricky. What's the other example? There's a couple more where they kind of throw you off a little bit. I guess, oh, that's it. I've kind of got the one. So for example, the only one which will really throw you out will be when you have two numbers that kind of shouldn't necessarily be the same. So I'll show you an example. Another one should be, let's look at magnesium oxide. Ooh, why did I do a Q? All right, oxide. So I'm following the same steps. So I write down my metal. All right. Now I know this is an ionic substance because we've got a metal and a non-metal. So I'm going to write down my first element, so magnesium, and it's got a 2+ charge. Oxygen has got a 2- charge. Now, when I do my crossing over, I get this. But that doesn't make sense. We shouldn't necessarily have that because really, magnesium's donating its 2 electrons to oxygen. Therefore, both should be happy and there shouldn't necessarily be 2 of them. So when you see this case, we actually need to simplify these numbers to the lowest they can be. So really, when we're looking at this, 2 and 2, it's actually the same as 1 and 1. So what you really should write here is it becomes magnesium oxide, and that is the element's that's the chemical formula for it. So because of those electrons, the crossing over method is sometimes a little bit flawed when it comes to these ones. But that's why when you're doing this, you'll see that magnesium oxide, you'll probably write it as Mg2O2, but that doesn't exist. It's MgO, and that's due to those valencies and where the electrons are moving. So hopefully this helps. What I'll do is I might upload this for you. Again, these rules were just simply the ones that I typed up really quickly, so they might not be perfect, but follow the same structure. It's the IDE. Slowly but surely looking at the symbols. Your main thing is always to confirm your first step. Number 1 step, oh gosh. Number 1 step, figure out if you've got ionic or covalent. And that is the most important steps because as you can see, they've both got different naming schemes and different things you need to assume. Anywho, I hope that goes well for you. Have a good one, girls. Just let me know if you need anything you've got today, tomorrow, and then we'll go through these answers on Monday. Take it easy.